Hello everyone. Today I will just walk you through the responsible AI principles and also fairness considerations in our Taiwanese bankruptcy prediction model, along with the steps taken to improve model interpretability. As business increasingly rely on the AI-driven and also decision-making, ensuring the fairness and explainability is essential. Financial industry in particular must adhere to ethical AI principles to prevent discriminations and also promote transparency. The model we developed is aimed at predicting corporate bankruptcy risk while also upholding the RAI principles. The RAI principles and fairness, ensuring the fairness and mitigating the biases is crucial in any predictive model, especially in financial risk assessment. Here's how we address these concerns. The data set exhibits a significant class imbalance with a relative low number of bankruptcy companies to non-bankruptcy ones. A model trained on such an imbalanced data set may end up biased towards the predicting most firms as non-bankrupt, thereby also underestimating the real bankruptcy risks. To prevent our model from being biased towards the majority class, we employed Smolten. This hybrid technology generates synthetic minority samples while also cleaning the potential noise, improving the model robustness. By balancing the data set, we ensure that the model learns equally from both bankruptcy and non-bankruptcy firms, leading to more accurate and also fair predictions. We also use stratified random sampling to maintain the original distribution of the bankruptcy classes, ensuring the training data was representative of real world cases. This method also prevents accidental overfitting to one class while maintaining the statistically integrity in the learning process. For the feature selection to reduce biases, instead of just arbitrarily choosing the financial ratios, we use RFE with random forest classifiers. The RFE ranks features based on the importance, ensuring that decisions are not just based on the potentially biased or irrelevant predictions. This step prevents the model from relying on correlated but non-causal variables, ensuring fairness in decision making. Additionally, feature selections improves computational efficiency and model interpretability by reducing the complexity.
And we also applied stratified k-fold cross-validation, which ensures fairness across different training test splits and preventing performance inflation due to data selection bias. This step ensures that the model performs consistently across different subsets of data, making it more reliable in production. And beyond technical adjustments, we conclude bias analysis using statistical fairness metrics such as demographic parity and equalized odds. By evaluating disparities in prediction errors between different groups, we ensured our model met ethical AI standards and complied with best practices. And we also improve model interpretability by understanding how a model makes predictions is essential for business adoption and the regulatory compliance. We integrated the following methods. First, RFE. By reducing the number of features to the most impactful ones, we ensure decision makers focus on the key financial indicators that drive bankruptcy risk. The final model uses only the 5 most predictive financial ratios, making interpretation easier. And we also use SHAP. SHAP values assigns important scores to each feature for individual predictions, explaining why a company was classified as bankrupt or non-bankrupt. This transparency supports auditability and compliance with financial regulations. By using SHAP summary plots, we identified which financial metrics drive risk the most, helping businesses make informed decisions. And LIME. For individual cases, LIME generates human-readable explanations, demonstrating how slight changes in financial ratios can affect bankruptcy risk. This makes the model predictions actionable for risk managers and financial analysts. LAM was particularly useful for case-specific risk assessments, allowing financial institutions to better justify decisions. And also we visualize the executive communication. Executives and financial stakeholders require intuitive insights rather than complex AI explanations. By leveraging sharp and live visualizations, we created easy-to-understand charts that highlight the impact of different financial ratios on bankruptcy likelihood. This ensures that risk assessment remains transparent and actionable. And we also value the business value and risk mitigation. A transparent model enables executives to assess risk exposure and allocate financial resources effectively and avoid wrongful loan rejections that could result from a opaque black box model. By improving interpretability, we mitigate regulatory risks associated with biased AI-driven financial decisions. And furthermore, by making model decisions more explainable, we increase trust among business leaders and regulatory bodies. Future improvements and ethical AI considerations. The improvements we made, while our model significantly enhances fairness and interpretability, we recognize that AI ethics is an evolving field. In the future, we plan to integrate counterfactual fairness approaches and further audit model drift to ensure continued compliance with AI best practices. And additionally, conducting stakeholders workshops with financial analysts will help refine how AI-driven bankruptcy predictions are used in decision-making. By integrating fairness-enhancing techniques and interpretability tools, we ensure our Taiwanese bankruptcy prediction model adheres to responsible AI principles and is fair in decision-making and provides explainable insights for executives. AI-driven decision-making in finance must be transparent and accountable, and our approach demonstrates how fairness and interpretability can be embedded in predictive analytics. By addressing bias, improving explainability, and ensuring fairness, we provide financial institutions with ethical, accurate, and business-ready AI solution. Thank you for your time.